thanks a lot for the introduction and also thanks a lot for the invitation. I think I come here every 5 years more or less, but COVID doesn't help. But it's always a pleasure to be back at UTS or to work on the pilot plan or just to give the seminar. I will try to present a bit of the research. I will try to present Lekia to explain you where we are, what we do, and also some research projects we have here at the moment. Title, I'm not super happy with it, but we talk about trying to go through circularity in water resources, also including the membrane management with all the projects we are ongoing now. So just to present it quickly, we are in Girona, which is not Gijón. So Girona is in Catalonia, close to Barcelona, in the north of Catalonia. It's quite a nice town, so feel more than welcome to visit us. As you can see, this is a Mediterranean region, and well, maybe you've heard about Girona. Maybe this doesn't ring a bell. This maybe more. So we're one of the city of Game of Thrones, let's say, to put it quickly. And so it's the Mediterranean region. So there is always this famous photo they show about like a nearby dam that we have, and we see this church which is flooded. So we thought, there is a flood. So in fact, they made a reservoir where before there were no villages. All villages, and what remains, so the only place that the part that we can see remaining from this old village is the top of the church. So you can even go on kayak and kayak through the church, in fact. So that's one of the biggest reservoirs in Catalonia, which is about more than 10 million people in the area. And basically, this is what happened when the reservoir is full. And what happened in 2008, you can see in these photos that there were the first big draw, and that was like a strong push because it reached the point that there were no more water for Barcelona. So in 2008, there were a strong push locally in Catalonia, so in Spain in general, because there are many regions where this is a big issue. A strong push for water reuse and desalination. I think nowadays Spain is like the leading country in terms of in Europe in terms of water reuse and also desalination. So that was in 2008, and this is what happened this year. So that was in June, and basically in June there were it hasn't rained for the whole winter, more or less, and we reached like something like 10 to 15% left in one of these reservoirs. Some were still a bit more filled up, but there were quite a lot of tension this year. And we reached the point that we had only 2 months of reserve. So like emergency situation. In this end, water reuse we were already working on, the desalination plant we were on. So even with all that, still under big stress. Luckily, we had quite a lot of rain in end of May, June, and even July, which was not usual. So nowadays, the situation is getting a bit better. And basically, the two main, apart from domestic consumption, there is a lot of agriculture and also quite some tourism activity, so which are consuming a lot of water. So to try to keep the economy, there is strong need for water. And basically, apart from this reason of water scarcity, like Girona in Spain is one of the hubs for water research, let's say. And I am currently working at Lekia, which is a research group of the University of Girona. And also we are working closely with IGRA, which is the Catalan Institute for Water Research. So like there is these two research groups which are quite strong, at least at the European level, and with quite quite strong with regards to the size of the city, which is only 100,000 inhabitants, and we have quite a strong activity on water research. So we organized in June a conference, and you can see here like people from Lekia, which is focused on chemical engineering, and the technological, like people working on water technology in ICRA. We are about 70 people doing research on this topic. And within this, we are in Lekia around 12 people now working on processes, not uniquely, but processes which integrate membrane processes. So this is just to give you an overview of all the activities we have in Lekia. In general, we have quite an integrated approach. So there is the water loop, let's say, also a bit air treatment, but we are trying to work on a very integrated approach. So that's why, apart from the technological, like Anamox biological system, we also have like this time of environmental decision support system, integration, and hydrology also sometimes, so more integrated at a global level. And yeah, so basically, we'll try to make use of the environmental problem to solve them and to make some products. So we are working around these topics, which include planning and management and control. And also I wanted to insist in the fact that among the membrane team especially, we are not only doing research but teaching. When I do teaching, it's not only teaching for the students of the university, but also we have some program that I will show later, and including cooperation projects. So we'll try to apply some of the research or some of the commercial membrane system existing to some teaching and cooperation projects. And apart from that, with regard to the topic we're working on, desalination reuse, anaerobic membrane bioreactor, which was like optimization of membrane bioreactor system, was one of the initial strong topic of Lekia. And it still is. We're working for a company for optimizing full-scale MBR in terms of aeration, cleaning, and such. And also working on different type of MBR, including nowadays we're developing a bit microalgae for the bioreactor. We're trying to develop also to have access to all kind of pressure-driven system, like all basic membrane system. We have also, I will explain after, you see here EcoMem, which is a spin-off that have been developed by Raquel Garcia, who spent some time at UNES as well, on membrane recycling. So now she has a company that is dedicated to membrane recycling. And also, we're working on working every day more on not only on wastewater, but trying to recover valuable products from wastewater, or even trying to produce valuable products through bioprocesses, like proteins. We start to work in food, volatile acid as substitutes to chemical industry. And also, finally, we're working also on integration, optimization of processes through artificial intelligence modeling, LCA decision support system. So more like a global approach. In the lab, well, just very quickly, we start to have now possibilities to membrane fabrication, even if it's very basic, especially compared to what Ludo or you can do here at UTS. And we do membrane module modification to try to adapt commercial modules to our needs. And we also have this is the part of the equipment that Raquel has, for example, for the spinner, for characterization of full-scale module and cleaning as well. So we have all kind of, from small scale to, say, middle scale, close to industrial scale pilots. And also we have the same for RO, so we can analyze from coupons, small modules to big one. And also now we're trying to work more and more on bioreactor, fermenters, microalgae cultivation, so we start to develop also this part of biological processes. This I wanted to mention because it's not a lot of money, but still it's quite a bit of time that we spend on that, and we like it a lot. In fact, we have, like, for example, this is a project that is running in cooperation with some university in France, Toulouse, Montpellier, and also focused on Southeast Asian countries, where we try to develop some teaching methodology based on problem-based learning, but also we kind of provide some masterclass. So we went, for example, to Cambodia to give some class on membrane technologies, also to try to work with master student, PhD student, and to try to see if they can follow up with some research, very applied research to the topic. And this is funded by Erasmus Plus program, and also like this year, like 1 month ago, we organized a summer school, so we had like 20 students coming from different universities in Europe, coming over to Girona. We had some online talks, with one from Lidl, and also the second week they all came to Girona. We did practice, site visits, and a lot of networking and good time. So the kind of activities that are quite nice to work in. Another approach we have, like this is, I don't know if you heard about this. This is developed by actually a Australian company, like using UF as a gravity-driven system to remove viruses from remote area, so when they don't have electricity or access to any kind of water except from rainwater or river water. So we have a project in Colombia, now we're starting one in Senegal where we implement those kind of system. And so there is all the social approach and so on, talking with communities to try to have them taking care of the system. But in parallel and before that, we also have in the lab ways to characterize those modules. We also work like with a French company, we help them to design the module and to optimize. So there is always not like rocket science research, but kind of development associated to this project. And yeah, circularity, going on to the research part. So when we talk about circularity in membrane processes, it's because, well, I guess it's the same here, but we're not only thinking of wastewater, especially with regard to wastewater. Not only about wastewater treatment, but water recovery, try to recover valuable minerals, and could be fertilizer, for example, as well. So we try to work on projects which are promoting water reuse, recovery of valuable compounds, try to limit energy needs for those processes, or even to produce energy, production of alternative fuels, proteins, and also through some projects, we also have tried to promote the membrane circularity, so the recycling or reuse of membranes. So there are several projects that I will go through now during my presentation that I'm involved in. So far we're dealing with different aspects of that. The first one is, this is actually my main research grant, which is called Forward Factory. So working with forward osmosis, which is still my main activity. So to try to make use of the osmotic power from the seawater to extract the maximum of water from the wastewater, to lead to low pressure, to have a diluted seawater that you can reuse for whatever water usage, depending on the legal aspect. And at the same time to concentrate wastewater, because one of the limitations of valorizing wastewater is that the high dilution in water of all the valuable compounds. So trying to harvest the water, concentrate the streams, and then to have more potential for valorizing those compounds, to treat them through especially biological processes. There are many aspects that we are dealing with this project, but one of the questions was, but how much can we concentrate? So we're still working on that, trying to refine the model. But basically, if you think of using seawater at 30 grams per liter, and you can easily achieve like 10, 15 times concentration. Then depends, of course, on the salinity of the feed water, of the wastewater, depends on the arrangement and so on of the forward osmosis system, but just to give a rough number. So there is quite some potential to extract a fair amount of water from wastewater thanks to the seawater. And another question we had is like, okay, what if we dilute seawater? if we dilute seawater, what will be the benefit in terms of energy and water quality from the permeates of the reverse osmosis? So I have a PhD student who started working on that, especially on using, well, she compared different design systems from manufacturer, marine manufacturer, to try to have some idea of that, just to see what could be the objective, what will be realistic in terms of achievable objectives. And what would be the interest of diluting? If it really makes sense, and until when can we go, basically? And one of the questions we had is, if we already have a desalination plant operating, is it possible to dilute the stream? Will the desal plant still be functional, or is it nonsense and we can better start with a new desal plant? That kind of question that we try to solve. In theory, this is the main interest you can have. So the low energy usage because you dilute with wastewater, you have your water recycling, you have reduced aroma fouling and also multi-barrier protection from the wastewater because you have FO and RO membrane, so double dense barrier, especially to avoid to have a very high rejection of all organic microcontaminants. So, well, she did a lot of calculation, but this is one to try to sum up. So we started with like design with a typical desal plant where you can produce 1,800 cubic meter per day of permeate. And if we have 45% recovery using seawater as feed, well, it will consume around 2 kilowatt per hour per cubic meter to produce seawater. This is what comes from the software. It is like, if you look at all the software, they come to the same results as soon as you have an energy recovery device, and depending a bit on the design you choose. But that was our starting point. And then we started to check the impact of dilution. So if we dilute, what happens? What are the potentials? So here, for example, you can increase the recovery of the unit, so up to 65%. These values basically are when we reach the alarms in the system. So the design software was starting to telling us that this is going to be an alarm because there is too much permeate, there is too low concentrate of that kind of alarms. So what we saw is that 5 grams per liter is very ambitious, but in this case you can, for example, increase the recovery to 65%, produce 2 times more water than the initial state, and have an energy consumption which is more or less half of what would be a desalination. So some potential here to produce more water, to reduce energy, thanks to this system. What we saw also is that there could be an interest in boron rejection, well, to reach lower boron limit. That is actually a problem in the desal plant, that they normally put a second pass out sometimes because they cannot reach the boron limits, which increase a lot the energy requirements. Also, while we had relatively low TDS, but still within the specs, and while we took care of this. So we still want to work and talk to industry to see, well, what the software gave us, is it relevant in terms of industrial design? Because it's important to know if really what what we show through these softwares is really very relevant at like full-scale design of the plant. Another approach that we went through the forward factory project is like how we could integrate forward osmosis with biological projects, with biological processes. So it's just an example that in this case we work with ELM from Montpellier, to where they had a project on the granular anaerobic membrane bioreactor. If we can couple system with forward osmosis, what would be the benefits, limitations of the system? So here we saw that we could increase the COD removal above 90% when we implemented some micromembrane system. We have some limitation of salinity increase, so probably it's not the best design, but we are working around different concepts to have a clear idea of how it would be the most relevant to integrate FO concentration, or even compare with other membrane technology to see if it would make sense, basically. This is another test we did, for example, we're working on one side on microalgae production and optimization, and on the other side on the microalgae concentration. So we're trying to see, like, through submerged system, for example, what are the optimized conditions to have efficient microalgae concentration. So I don't know if you're aware of that, but concentration of microalgae is one of the limitations of the development of microalgae, because they are very, very diluted. And then it takes a lot of energy to concentrate, extract them. So if we could work on the efficient concentration of microalgae, that's also of interest. What we saw, well, it's not fully surprising, but when you have air scoring of your submerged membrane, you have very low fouling, and then you can concentrate efficiently on your microalgae. We compare microfiltration for osmosis, leading to the same concentration, leading to similar flux and operation. The difference is that with for osmosis, we had a high rejection of all compounds, not only microalgae. So we had microalgae concentrate. On one side, we have like pure permeate, but on the microalgae side, you can concentrate all the other compounds you had initially, and also a bit of reversal diffusion. That would lead to a very saline microalgae batch, basically. Another project, we're working on this through industrial doctorate and funding from the Catalan government, which is they're working with this biotech company startup called Biotech, whose aim is to take the organic waste, mostly liquid waste like wastewater coming from agro-food industry, transform them in through fermentation to volatile fatty acid, and then do the purification to produce most likely PHA, so as bioplastic. And one of the critical steps in the process was that, depending on the type of waste, but the concentration of volatile acid, that fatty acid that they produce from the fermenter is maybe around 2 to 5 grams per liter, and ideally they would need 50 for the optimization of the PHA production. So working on that and trying to see how through different membrane processes we could try to concentrate, potentially purify those VFA, and so we've been, we are still here in the project, so still at lab scale, comparing FO, RO, NF as well. What we see, like, of course, depending on the pH of the batch, you have different rejection mechanism through the membrane. Basically, more or less, RO and FO will act the same in terms of rejection. But basically, in that case, for example, when we have a pH above the pKa, so you have size exclusion and exostatic interaction, we manage to concentrate 20 times our volatile fatty acid. So 50 grams, which are our initial target, is possible. So 50 times, and also is a very high recovery, so we don't lose those volatile fatty acid through the membrane. Another project, so it's more about the membrane recycling, where we work here together with people from IGRA, with Pierre Leclerc from USW, with one of the reasons I'm here as well, and with Ludo. We have this project Osmo for Life, which the aim is to give for life to a reverse osmosis membrane. So that's the overall aim of this project, with the idea that from a seawater reverse osmosis membrane that is about to be discharged, we can transform it to brackish water, then to NF membrane and UF membrane, and find and try them in application for all those applications. Through this project, we are working on several aspects, and also not only trying to degrade those membranes, but also to try to understand what is the consequence of wrong management of the membrane and how can like drying and chemical attack, oxidation will affect membrane properties. And so we do that. We try to optimize in case we want to recycle, change, transform the property of the membrane, try to optimize the process, so at lab scale and going through a pilot scale, and also test those membranes into real scale application. So this is like just one graph to explain you, for example, when the membrane, like seawater reverse osmosis membrane was in contact with chlorine, depending on the contact time that you have, you can increase the permeability and decrease the selectivity, which is what the main reason is that basically you attack the polyamide layer. So you're degrading your polyamide, the membrane is getting more porous, lose its rejection, but increase its permeability. So depending on the level of attack you want to do, you can change the property of the membrane to change it to NF or UF membrane, for example. This other one is about drying. So what we saw, it's like if you let the membrane dry, you will also lose the permeability. And depending on the solvent you use and so on, you can lose the permeability of the membrane. So you can lose the initial property of the membrane. So drying could be also a strong limitation to membrane recycling, depending on how they were stored. And that's an example, for example, of reuse module. So in this case, it's like tertiary treatment of wastewater, and the wastewater treatment plant close to our research center, where the old seawater reverse osmosis module have been transformed to UF or to UNF, and then we try to see if they can work in a gravity-driven application for the removal, like polishing treatment of a tertiary treatment. So we saw that we still have to go every day, try to clean a bit the module, but we had operation during now above 2 months, I think, of operation, where we can produce permeate, pretty good quality permeate, and especially we had a look on removal of coliforms, where we can reach, depending on the membrane and the configuration, reach log 3, log 4 removal of those pathogens. Another one that is a bit like connected to all the research that have been developed here at UTS about the FDFO, so like fertilizer drawn forward osmosis system, which is used to use a fertilizer which has high osmotic pressure to dilute it with the type of wastewater. In our case, we are focused on greywater, and the idea was to implement it in a hotel where all the greywater from the hotel can be collected and used to dilute fertilizer solution. And with the challenge is like this dilute fertilizer could be used in a hydroponic system. So one of the question of limitation of this process is to see, can we dilute down to what is required for the plant, which was one of the research questions they had here as well. In our case, in some cases, when you play around the type of fertilizer, you can reach something that is close to the requirements, but still it's very challenging. Especially depending on the type of wastewater you have, and conductivity especially, and what the level of the dilution you can reach, because you have to extract really a lot of water from the grey water with a small amount of fertilizer. But we managed to get to some levels that were acceptable to be tested on plants, let's say. So yeah, we have some, especially in IGRA, this is in IGRA, the research was mainly conducted from IGRA, where you have hydroponics lanes and you can compare different type of fertilizers with different type of wastewater, doped eventually with some micropollutants, and check later on the development of the plants. So on one side, we observed that there were a decent development of the plants, not as good as if clean water was used, just mixed with fertilizer, but pretty decent growth. And also one of the interests that is in this case that we try to evaluate is the rejection of all the organic, maybe it's not in the title, see, the rejection of micropollutants from the grey water in this case, which was very high. So this is also one of the interests of this configuration, that you can reject a lot of microcontaminants for direct reuse. Another topic we've been working on is our colleague Narcisse Pousse, who is working on the production of proteins based on bioelectrochemical system and urea or any source of ammonium. So his research is really more on finding the good biological source, and also to try to optimize the system. But basically, they are producing, which we call them HOV, those bacteria, which are full of proteins. And the idea is that this bacteria later on could be used for example, as feed for fisheries. So now they are kind of having a process that is quite stabilized and start to produce quite a lot of quantity. And basically, then we talked and we said, well, I need to concentrate. So how can we do that? So we did some type of test, some tests to try to see by different type of membrane technology if we could concentrate, like extract the water, but also concentrate the proteins, which is also it's not the only project or topic in which we're working on that. It's like you have to extract the water, so to concentrate your feed water, but also you have to concentrate your products. So be sure it's not going through the membrane, be sure it's not found on the membrane and lost. So there is all this approach on how effective is the concentration and how far can you go. And in this case, for example, we managed to have a concentration factor with microfiltration up to 10, here above 15 times. So, and it's not like the limit of the process, we can still optimize. But this is where we are now. So that it's quite interesting for them to already have this concentration factor, because it will help for the scale-up potential. And well, conclusion, just to repeat a bit that the approach we have in Laker, but I think, it's probably a general approach that all over in the world now, especially in all the European area where a lot of funding are coming from the EU, and all the national plans are connected to the general view of the EU as well, is that moving from wastewater treatment to resource recovery on one side, so trying to get more valuable components from any waste, but also have a global approach, integrated processes. Most of the goals, most of the projects now are integrating social aspects. They're integrating overall environmental evaluation. They want also projects which are integrating water, energy, and food. So it's not really all the topics, all the goals, most of the research projects are not focused on one specific technology development. They are more integrated in a much broader scope. Well, thank you. Wanted just to set the here acknowledge most of the funders we have, and as Ludo said, we are welcome to Girona. You can use this opportunity because we are very close to Sitges, so it's less than 2 hours, so don't hesitate to pass by. Thank you.
For this nice presentation. I think our audience are very interested in this topic. So anyone has question?
I've got a few, but I'd like to give the opportunity to others first.
Yes.
All right. Yeah, unbelievably interesting. Equally, Dr. Udo as well. The wastewater, right at the beginning, you started with you're recovering some nutrients from the wastewater. First of all, what sort of wastewater are you using, please, sir?
Urban.
Pardon?
Urban, like municipal.
Municipal wastewater, so just mixed feces and urine, so mixed, not segregated.
No. Yeah. Well, we
Okay.
try to focus the project on what is the typical composition of municipal wastewater. You will
Yes.
find this for Europe.
Okay.
So it's